Well, where is everyone? No one is saying hello in the chat. So hello, Lionel. I forgot to switch the screens on the other side so we could be a bit more. There we go. I'm going to do this. There we go. So that looks a bit more natural. I can look at you. Oh, hello, Jose, and that I assume that we are audible. And Jim, how's everyone today on another wonderful Wednesday? I have to look at my calendar. I'm a bit absent-minded today, hay-brained or whatever you call it. And as you can see, we have amazing master trainer, amazing artist, teacher, and very good friend, Lionel from France, that is going to give us the second installment of his amazing series. How are you, Lionel, today?
Hello, I'm fine. I'm eager to start.
Good, good. So allow me then to just, before you start, to go through the quick housekeeping. So I'm going to bring up this and post some links. So pay attention to the comments, everyone. And let me go and start copying and pasting things. If you want to go to this, let's say, general page, just click that link. I'm going to post right now. And there it is. And on this page, you will find the Maxon events page, which talks about all the events that are ongoing. It will provide you links to the training team YouTube channel, Cineversity, your free t-shirt. I'm going to tell you the code in a second. And of course, to post your questions for the Ask the Question. Yeah, I told you I'm a bit hay-brained today. To the Ask the Trainer, which the show is on tomorrow. And I'm hosting it, so I'm looking forward to checking out your questions and providing solutions. And amongst other stuff, certifications, and generally sign up to get the newsletter and get information directly from the horse's mouth. Now, in terms of YouTube channels, the Maxon Training YouTube channel hosts these videos after they are recorded with timestamps and comments provided by our very good friend and mentor, Dr. Sassy. He's keeping us in check in the background. And of course, the Maxon YouTube channel, where we have amazing presentations and videos. And oh, look at that, Lionel. And don't forget to go to the Maxon ZBrush YouTube channel and see the amazing work that people are doing, watch tutorials, presentations, and just be amazed and feel envious about the amazing stuff that other people are making. I'm not talking about you, I'm talking about myself. And if you go to that link over here that says, get your t-shirt. Once a month, you can claim a free t-shirt. You only pay for postage and packaging, folding, and ironing, and all that. And the code for the month of October is the rolling cones, all capital letters, no spaces. And it's in the chat now. Let me see if I can bring up a banner just to have it there. There we go. The rolling cones. That's a funny one. Fantastic. And of course, don't forget to go to Cineversity to learn Cinema 4D and all the other amazing products we have in our Maxon One suite of products. And with that said, I think it's time to exit the housekeeping and allow Lionel to go through his amazing stuff. So I'm going to add you to the stage. If you can get rid of the feedback window, I'll keep you in check. Don't worry.
There we are.
I've got my eye on you. So let the show begin.
Thank you, Genesis. So, hi, everybody. I'm Lionel. So we're going to see today some simulation stuff on how to construct that kind of thing. So this one was last week, and I hadn't time to do the flag here, so we're going to start with that. And then we're going to construct a few mechanisms like this for building our kit. So let me show you just before this
Wait,
is.
wait, Lionel. I
Yes.
forgot to say something very important. I was wondering, what did I forget? What did I forget?
I was going to talk about it.
Let's say now at the beginning, I'm going to post 4 links in the comments. And Lionel has provided the viewers of our show with codes for his online courses on Udemy. And do we need a sound, something like 70% off each course? It may be 80, but anyway. And I'm going to post the links while Lionel is talking. And at the end, if Lionel has something to add to this, we will do that. So keep talking about this amazing project, and I'll paste the links.
Thank you. So yes, this is the big marble run simulation I did a few years ago. So we're not going to do that because there are too many components and so on, but we're going to see a few things. So today, in particular, we're going to see this thing, which is the piston setup here. So let me just take a look at this. I can see everything has been cached, and this is a simulation because that would be very difficult to do just with constraint and so on. And that's possible. So we will see that piston setup right after the flag. And also we'll see how to build a few components of this marble run. So this is the new one I've just set up last week. And this one will be the topic of the third show because it's a marble run kit. Meaning that you have all these elements, then you can just duplicate like this very easily and create your own marble run. So for this, we will see how to construct these blocks, how to assemble them. But all these things like the Ferris wheel here, and especially here, the separator, divider, distributor, I don't know how to call it, that just distribute the marbles like this. I even have a rendering that I forgot to load. So yeah, maybe I'll show you. Yeah, no, I have it. Just wait a second. Still a bit rough, but this is the whole thing. So that will be next week. But we will see how to create this thing, the distributor, and the Ferris wheel. And next week, how to assemble everything. So it'll be a lot of fun. And it goes back to the beginning, and it goes on and on and on and on. You can keep it playing like for hours if you want. So let's start. So a lot of things to see today. I hope I'll have the time to see it all. So first, I would like to go back to the flag animation we have here in this simple marble run, where we can see our flag is playing, and it's a perfect loop. So right at the end, 225 frames, it goes back to the beginning, and it's seamless. So I can play it forever like that. As you can see, when you go back to the beginning, it just goes seamless. So how do you do that flag animation to make it seamless? So let's start very quickly. So I'm going to start that simulation in another file. I like to do that because if you have several simulations, they're going to play against each other. So you might want to have a wind modifier or something like you don't want to affect others. So that's possible, but the simplest way to do it is just to create new files. You just have to be careful about the size of the scene, and you're going to cache everything. So here, let's go back to 200 centimeter. And I guess the height will be 125. And I would like to have a flag with a dent inside, a dent. So I'm going to make it editable. Go to the point mode. I'm going to take those 2 points, right click, subdivide. So I have a point in the middle, and I can do that. Okay. Now let's make it a bit smaller like that. I'm going to extrude and make it very flat, so 0 centimeter. Simple, just going to create a cap on everything. Okay, and now I would like to have some segments, because here we don't have any. So I have a trick here. I don't want to have quads, because with quads, it would be difficult to resolve here our pointy thing. Also, quads are not ideal actually when you're doing simulation. Well, they're quite good actually, and they are ideal in a lot of situation, but not every time. It can be interesting to have triangles, especially if you want to tear something up, and if you have complex shape like that. It's interesting also because it can create some wrinkles that you will have with the quads, but it will be very, very regular. So to create a triangle patch, I'm going to the caps and use the Delaunay with the density of 100. Now I need to go to my rectangle and change it to natural and increase the points. Okay, so this way I have a uniform, well, not uniform, but even distribution of triangles. But I don't like the fact we have those tiny triangles at the end. You can have triangles, but try to have triangles of the same size. So I have a trick here. I'm going to use the polygon reduction as a parent, and it's going to change the our triangles to something much more even like that. So I have a few that I don't like. I just have to find the right amount. Maybe play with the rectangle here. And that should be enough. And the density is good, I would say. How do I know that? Because I have done a lot of simulation. I know by eyeball that's pretty good for what we want to do. Okay, so we need to fix the flag. I could use the belt tag, but because it's just going to stay static, I'm not going to do anything with it. It's much easier to use just the dresser. But in order to use the dresser with the simulation, I need to convert this to an object. So I'm going to current state to object. So I have a copy, this one. I'm going to turn that off and get rid of this. I don't care about that. And let's go to the points, and I'm going to create a selection. So actually more the segments, the edges, and use here our edges selection. And I try to get this one, perfect. Control, click here to switch it to points. Okay, now I'm going to put my simulation tag, the cloth, and here to fix the points, because if I hit play, it's just going to fall down. To fix the point in space, I'll go to the dresser here, and I'll use here the fix point. So set, and it turns this purple, pink color. So it's fixed. Now, if I go back to the element like that, and the model, and I just hit play, it works. Okay, so we have here this shading issue because we're using our Fong tag. I don't want to have any Fong. Well, I want to have Fong everywhere. And now we need to add some wind because it's just going to stay like that, of course, because there is no wind. So let's add a wind. And here, let's orient the wind. And let's go this way, for example. And because we have gravity in the simulation here, we can see the gravity is this value. So almost negative 1000. I'm going to put a wind at least 1000. So maybe to 1200. And I'm going to add some turbulence. And that should do. And we already have a flag simulation. Okay, so it's a bit boring. And also, I wanted to make to last 225 seconds, frames, I mean, because this is the length of my animation. And if I hit play, I have something quite nice, but of course, at the end, it's not going to loop because it doesn't, of course. So first, I would like to add a more little bit more interesting stuff with the turbulence. So turbulence, not too much, with the scale, something like that, to have more wrinkles during the simulation. Okay, and because of the turbulence of the wind, sometimes it falls down. So this turbulence is actually the intensity of the wind, which is going to, well, to be lower and give this result, for example. So maybe a little bit less than that. And I want it to be more upward, so maybe 1500. And in that case, let's orient the wind more like this. So it flaps around. Perfect. One last thing I would like to do. Let's add to our extrude other tag, vertex map. And here I'm going to use the transfer to use the field and use the linear field. I'm going to assign some bendiness to the points. So let's go here. And I would like to have, well, the other way here, because I want to have, no, it was this way. Okay, something like that. I don't want to use the different points because I want to have a fixed state and then it's going to stay like that along the animation. So something like that. And if I go back to my tag, to the surface, I would like to play with the bendiness. So here I'm going to drag my field, my vertex map, meaning that when it's white, well, yellow, it's going to the max value here, bendiness. And when it's red, it's going to be zero bendiness, so that it's going to be a bit more, straight here at the beginning of the flag. So if I hit play, less wrinkle here, more on the right. Okay, so already I can play cache it. And now here is the trick. I'm not going to use here our cache here, but I'm going to use instead in rigging the point cache tag. This one is very interesting because it can just cache anything with points. If you want just the PSR, it's going to be transformed. Here I just want the points. I'm going to calculate it. So it's recording the whole thing. And now I'm going to turn off our tag because I don't need it anymore. So now it's turned off and I can play it through. And why did I do that? Because here on our cache, we have a very interesting feature here on the tag, which is the loop. Let's make it 2 loops. And now, if I just extend this animation, it's going to play again the thing, but still it won't fix the non-seamless issue. So I'm going to change my blend to 50%. And that alone is going to fix everything. So now if I just hit play, you will see I have a nice animation. And when we will be at 225, it's going to go back to the beginning and have a perfect seamless animation. And that's it. So actually now I can just take this thing, control, go back to my whole thing. I'm going to delete this flag, paste the new one. It's here. And now I just have to move it. Because it's cached, I can do whatever I want with it because it's cached. So let's put it here. Let's move it up. And actually, I don't even care about this tag and the vertex map and the linear field because, again, everything is cached. And I have my seamless flag animation. Of course, if I want to change it, I have to go back to the original file, do my thing, export it again. But what's cool with it, it's very easy, for example, here to orient it. So orient it, for example, this way. And fix it here again. You can see it's even, I could put it here because it's cached. It can be inside the ramp, the pillar here. Yes, that's better here. We can see it more easily. And when it's in the end, it goes back to the beginning with the perfect seamless loop. All right, so that was the easy one. So now let's move to more complicated setup with the piston. And maybe we have some question already. I don't know.
There was a question, but I think we need to hold it for the end. Thomas asks about the scale of simulations. So yeah, we'll check questions towards the end of the session.
Yes, yeah, because it's very important. You need to be very careful about your scale, and you very often have to cheat with it. So we'll see. So here we're going to create this piston setup, which is more difficult than it looks because it's cached and it's made seamless, meaning that again, I can extend it as much as I want. I can predict where it's going to be. And the ball rolling, the marble rolling on the thing here is simulation, and then it's going to be cached again. So let's start with the beginning. We want to create this line and the first simulation. So I have a file here. So this is the actual piston already cached, and I have another one. So this is going to be the end result. And as you can see, here the pistons are cached. I can change the speed, do whatever I want with it. And the marble here is not cached. So if I hit play, as you can see, it's live. And it's rolling, and it's rolling, and so on. So we have the nice thing about the simulation, that the marble can just bump into this, then goes back, then maybe gets stuck a little bit, and so on. But the pistons are behaving in a very predictable way because they are cached. And this way I could stagger the animation, meaning that they don't play all at the same time. I could desynchronize them and so on. So let's start with the actual piston setup. So I'm going to create a new file. I'm going to check my my thing to be sure about this. All right, okay, and we're going to create our piston. So here, because I don't, for this one, I don't care about the size, the scale. I can have something pretty big. I'm going to create first our hub. So the hub will be just a simple cylinder. And maybe I'll make it a bit smaller, like 25 of radius. And here, well, it will be maybe 25 too. And maybe let's make it a bit longer like this. So 40 centimeter. Okay, 32 segments of rotation. Then we're going to have the first part, which is going to be in this front view. I'm going to create a rectangle, make it big like that. For example, 60 centimeter because I like round number. And we're going to change the height a little bit and use the rounding all to the way to get this. Okay, so now I'm going there. I'm trying to eyeball to have something nice like that. Okay, so now let's go back here. Let's put it inside extrude with a small extrusion, like maybe 10 centimeter or even less, 8 centimeter. Okay, and this is going to be here. Okay, and this one I would like to have two of them, so I can just cheat it by using here the symmetry. Okay, and the symmetry will be on the z-axis, so not the x, z, right? And now if I just move the extrude, I can move it like that, and the symmetry will be like this. So always remember the symmetry location, the location of the symmetry is going to be your location, and the location of the extruder will tell you how much you're going to move them from each other. So once we have understood that, it's very easy to change. All right, so now we're going to create the shaft, which is a cube. We're going to make smaller, a lot smaller, like that. And maybe something like this, and move it this way. Okay, and of course, very thin. And again, I use the 4 views to see where I'm going. Okay, so something like that should work. Maybe make it smaller, we'll see. That should do it. Okay, and now we need to make the piston head. So again, very easy. We're going to create a cube, make it smaller, and 50 centimeter, why not? Okay, and I'm going to move it here and put it like here. Okay, so we'll need to have enough room. Well, we'll see when we had the animation. This shouldn't touch the top of this thing here. So that should be enough, I think. And we need to carve this piston because the marble is going to roll along. So here I'm going to use a cylinder using control to put it right at the center of the cube. And on the z-axis, reduce the size. I'm going to move it up. And I would like to put this thing, the axis of the cylinder, right at the center of this polygon. So to do this, let's use snap, polygon, and use the midpoint. Okay, so now I can just do that, and it's perfectly snapped in the center. Okay, so now let's reduce the size, have a little bit more rotation segments. And if I want to have the thing moving to the right, I need to create a slope for our marble. So something like that. And I'm just going to do a Boolean. So use my cube, use the Boolean. Second one will be subtract. And here we are. So this is our piston. And I would like to make it a bit smaller, like this. Okay, so that's the first step. I'm going to save this in case of a crash or whatever. So piston web. And now we need to create all the mechanism and so on. So I'm going to name them. So this is the hub. Well, I don't know how to name it, but let's name this one shaft. And this one
a push rod.
Push rod. Okay, if you say so. Let's push rod.
Or we call it in Greek biella. Maybe there's a French word.
Yes, biella. Same word in French.
We use a lot of French words in Greek when it comes to engineering.
All right, so here now we need to create all the mechanism. So since, well, 2025, I think, since this Cinema 4D, we have all the simulate object, the spring, the motor, and the connectors compatible with the new dynamic system. So we're going to use that. And first we need to make the hub rotate. So that will be a motor, okay? So I put the motor right here. It's aligned with our hub because it's the center of the world. And my motor is going to ask for an object. So everything that's the dynamic object we're going to create here, those one, need to have a dynamic tag. So my hub here is going to be a rigid body. Okay, so now if I put my motor and I ask for the hub to be put here, it's going to work, but if I hit play, of course, it's going to fall down. Okay, we can see there is a connection because there is a line following, but it doesn't hold in place because there's nothing to hold it in place. So we're going to create also a angular hinge. So angular here is going to create this one, which is a hinge. Let's make it a bit bigger, like that, so we can see. And it's in the right axis already. So I'm going to ask here in the object, I'm going to put the hub. And now if I hit play, well, we don't see anything because I need to see the segments. And as you can see, we have our thing rotating. So let's take our motor. This is much too fast. Let's make 200 degrees seconds. And the torque, which is the power, let's make it huge, like 2000, because it will need torque to move everything at the end. So if I play, now we can see it move. All right. So now we need to connect that to the rest. So actually here, our push rod here, we can put it just as a child of this one. It's going to work. I don't need to make this a dynamic object. It's just going to work like this nicely. Okay. Now I'm going to create a new connector because I want to connect the different elements together. So let's create a new connector, which is an angular connector, and I'm going to put it somewhere here, okay, on this axis, something like that, okay. And this connector is going to connect the hub and the shaft. So before I forget, I need to put simulation tag rigid body on everything that's going to be dynamic. All right. So now if I hit play, we have this. Makes sense because our push rod, our shaft is connected. And you can see here the hinge doing its thing, but there is nothing with the head of the piston. So we need to connect that too. So let's create yet another connector, angular. Let's move it up right here. And we're going to ask for this connector to connect the shaft and the head. Okay, and the head here, I need to, yes, create single object because I think it's going to broke something like that. So this is just a single object. So now if I hit play, we're starting to get something. It's quite funny, but it doesn't work. We need to do something else. We need to constrain all this on the y-axis. So this is yet another connector, which is going to be a linear connector. So this connector needs to be oriented the right way, this way. Shift. And let's put it here. And now this connector has the head connected. Well, that's it. This is just the single thing we need to put inside. So now if I hit play, it works. And as you can see, it's too low, like this. It just goes inside the thing. So we're going to make a few changes. Let's make this a bit bigger, like this. Let's move the head upward. And of course, I need to change our hinge connector, which is here, somewhere here. Okay, let's hit play. Okay, that's better. Now this is the right amount. And it's working. So we have our piston working. I can change a few stuff if I want. Change the speed and so on. And as we can see, it's not already linear. meaning that the speed is faster when it goes down because of the weight of the whole thing. Then it goes up, like it has some effort to do. It takes some strain to do the whole thing, and that makes it look more realistic. So now comes the difficult part, because I've had some bugs with this. Basically, you need to, if you want to cache everything, you can't keep it parametric. Okay, it didn't work in my trial and error, so I don't know if it's a bug or a limitation. I would say it's a limitation. So I'm going to make everything editable. Okay, so let's save this. I'm going to save incremental, and now I can make everything editable. So Shift C, C, and C. Okay, the push rod, we don't need to do anything with it because it's not dynamic anyway. So here I've lost my tag. I don't know why. Let's put our rigid body back. Okay, and I'm going to check that everything is connected the way it should. And it is. Last one, yes. Okay, let's hit play. And it works. Okay, so perfect. Now I can cache everything. So I'm going to save again. Take all this. Let's go to cache and make it cache scene. So now I can just move along like this, and we have something pretty nice. And now I would like to cache it again, but make it an Alembic file. So why do I want to do this? Because Alembic is rock steady. When you have an Alembic file, it's not going to do anything funky. It's not going to crash or whatever. It's solid, and you can do more things with the whole, with everything. Meaning that you can offset it, you can repeat it, and so on. You can attach object safely, which is not really the case when you are just here. Because I want to duplicate everything, I want to stagger them, I want to offset them. Keeping that cache system here is a bit dangerous. So what I'm going to do here is use a knit function, which is here convert scene cache to Alembic. Okay, so let's do this. It's going to ask me to do something, to put it somewhere. So let's put it here, and let's call it piston web webinar. Save. And now it's going to make the animation. All right, and it's going to ask to do it again. I don't know why. So I'm just going to cancel because it's there. You can see it's these 3 files. So now the difference is we have some Alembic file somewhere. And to use it more easily, what I'm going to do is actually open a new file and just import those Alembic file I just created. So it's here, it's piston here, webinar, the first one. Here we are. Merge with the second one, which is here, and merge with the third one. And if you would play, we have the whole thing. Okay, we are missing one element, which is our thingy, the push rod, because of course it hasn't been cached. It's just this object. I just need to copy it and paste it here and put it in the right place, which is this one. So I can just make it a child, and that's it. So now, like I said, it's rock steady, meaning that I can do whatever I want with it because it's pure Alembic. So I'm going to save it. Let's save it piston web 03. And now what I can do is just play with everything and make a loop. So first, I'm going to take the 3 thing, and here all the loop animation is here. I'm not going to use the animation. I want to use the frame, meaning that I can just control it like this. Okay, so let's start at 0. And I'm going to make a 50 frame loop and just find a frame that will fit seamlessly. So maybe let's go to this view and reduce 1. Okay, let's create a keyframe here. So now I have created the whole thing. Okay, and here it's stuck, of course, because I'm using the frames, so there's no animation anymore. To make it loop, let's use here our dope sheet. I'm going to take those 3 and have the track. I'm going to ask after the end of the keyframe to just continue. Repeat, because it's just repeating frames. And now I should have a perfect loop. Perfect loop that lasts exactly 50 frames, or 55, or just 30, or 75. See? That's why I took such pain to do this. And that means also that this whole thing, I can just put a null object, put everything inside. Okay, so we have our whole thing. And let's call this piston 0, 1. And I can duplicate it as much as I want. So I'm going here. Let's duplicate, duplicate, duplicate. And I could go on like that. And now what's nice is all these animation are contained here. So actually, if now I take the first one, which will be the last one, okay? So this is here, okay? Those 3. Now if I those 3 here, if I take the 3 next, will be the one on the top. So actually, let's select like this, so we can see exactly. Now I'm going to offset it, okay, like 15 frames. Okay, and same for the other. So now I know it's by 3, so 30, and now these by 3, 45, and this that would be 60. Okay, and I need to slide everything because they're going to start with some, you see, that's interesting, but I'm going to take everything here and move it like that. So now we have everything set up the way we want, with the staggering, like this. We can change the speed, do whatever we want with it. So that was just to show you that you can do anything you want. Let's go back several times, and to make it work, we need to offset only by an element like that. Okay, something like this will be more logical. Okay. And I would need also to move this a bit inside so that they're going to touch each other a bit like this. Okay. Same for this one. Same for this one. And the last one. And now, because they are seamless and infinite, I mean, they could run for thousands of frames, I can just add my marble. So let's create a sphere, make it the right size. Let's see here. Yes, it seems to be pretty good like that. Maybe a bit big. That should do it. And now let's use a rigid body simulation. So my final sphere is 16 centimeter. Okay. And I need, of course, to take all this and make them as collision object. So let's take all of them. Right click, collision, collider. And here my sphere, maybe I'll need to change the thickness here. Too fast. Also, I think the thickness should be a bit lower. Yeah, it's too fast. So the nice thing here, I just need to take this and increase the length. So everything's going to go faster, slower, I mean, and take the right element here. Make them start here, for example. And I would say it just need a push like our wind modifier, something you use a lot with that kind of setup. And this one, wind, can be very easy because you don't need to constrain it with the fill or whatever, because we only have that in the scene. And so on. So a lot of tweaking to do to have a nice animation in the end, because here it's far from it, but I have everything I need to make it work. You have the whole process. It takes a fair number of trial before you can find the right setting, the right amount everywhere, but it works. It's pretty fun to do. If I go back here to our, no, not this one here, you can see I could find the way to move it just like that. Well, it took me some time to find the right balance, I can tell you. And this is how you can create your piston setup. And I'm surprised I didn't fall into any trap and I didn't have any bug. Just remember, when you're going to do your caching here, to have everything as an editable object. It didn't work when I tried with parametric object, which is a shame. Again, I don't know if it's a limitation or a bug. Anyway, just file a bug to the team, and we will see how it will turn out. So what time is it? 48. That's not bad. I have time to show you one last thing. Maybe we have some question about all this.
Yeah, we have a couple of questions there, since you insist. The one I mentioned previously from Thomas is there a rule of thumb when choosing the scale of dynamic objects, especially if the real world scale is very small? So I'll let you take a shot at it first.
You should aim for the real scale, but like you said, if you're going to, for example, the coins, if you want to make a pile of coin tumble, for example, it's going to be very difficult if you're going to create coins in real life size. You'll be better off creating something bigger. It will work better. But if you create something too big, it will behave like the real world. Very good example are dominoes. If you create dominoes 1 meter high, they're going to be very slow they're going to fall down very slowly, because if in real world, if you make dominoes with something 1 meter high, well, it'll be slow. But if you create tiny dominoes, at some point it's almost going to break. So actually, you have some stuff you can try. Here, the scene scale is very important. Very often, I lower it to 10 centimeter. That's what I will do with the marble run, with the kit marble run next week. And then, if you want to slow everything down, well, you're going to play with the gravity, lower it. You can play with the time scale, but if you play with the time scale, you're going to have some skip in the animation, so you will need to raise the substeps. Well, it's difficult to balance everything. So try to have the real size. But I can tell you, if you go lower than 5 centimeter, it's going to start to behave strangely. So you can get by tweaking all this, upping the substeps and so on, but it's a lot of work. So it's better to cheat a little bit with the scale. And if you make it, yes,
go ahead. You finish what you say.
And if you make it too big, well, it's going to be very slow, but it will be more stable. But if it's too slow, you're going to increase the time scale, make it faster. Then it's going to fail because you need to increase the substep and so on. So it's like a vicious circle.
There are a couple of other things in terms of faking it. You can make things in bigger scale, render them out, or render every fifth frame to speed it up by 5 times, so that you compensate the speed with the size, and it should be a linear correlation between them. If something, you make something that is 100 times bigger, instead of 2 centimeters, it's 2 meters. I think that you need to increase the speed by a factor of by 100 or something like that. You can test, so you can fake it. Another thing that a lot of people forget is that the default collision distance is 1.5 centimeter. So if you're making a coin that is 2 centimeters, or if you're making a cloth which has points closer than 2 centimeters, you're going to have self collisions, intersections, and so forth. So make sure you go to the thickness parameter and make the actual collision thickness much smaller, so that it's logical. Increasing the substeps is something that's going to give you much better results, because the other issue is accuracy, right? If something that is 6 feet squared or 2 meters squared, 1 meter 80 squared, is falling, then even if it goes off by 1 centimeter or 2 centimeters, it's not really visible. But imagine a coin which is 2 centimeters to have an error of 2 centimeters, right? It's going to be totally out of position. And increasing the substeps increases the fidelity of the simulation up to a certain degree. If you do it too much, then you get GPU errors and so forth. But what Lionel said, cheat a bit, make things go faster, play with the scale, and get a visually pleasing result. The second question we had is this one here, from my compatriot. Can you please make some magic and try to have a cloner instead of copies? That is possible. One piece of advice I have for this is, when you clone an alembic, there appears to be some weird issue. But if you take the alembic, there's a solution for that. If you can do that, Lionel, just if you're done with a scene here, remove everything except for one, and go and make all 3 alembics. Press C to make them editable. So what happens if you make an alembic file, an alembic generator? What you see there is an alembic generator, the one with the A. If you make it editable, it makes it a mesh object and transfers the alembic data to the point cache, which is that little A tag. This will be cloned properly. So if you take this, put it under a null, and put it under a clone, it's going to work properly. Offset, make 2 copies of this, and offset one by half your frames, and you're good to go.
All right. Yeah, something I tried to use Alembic with cloner, and I just failed. But I don't remember if I try with this one.
Yeah, it's
So maybe
the difference
yes.
between the generator. So although it has an icon that looks like a mesh object, the actual Alembic file, it's actually a generator. It generates the geometry on the fly. This one, you get a point count. It only works with
Mm.
stable point counts. Uh, but the object is there. It's an actual mesh object, and the tag works as a deformer. It just moves the points around. So if you ever have any problems with cloners and Alembic files and whatnot, which you shouldn't, but if you do, just make them editable, and the Alembic data becomes a tag. Make sure they have a stable point count, and you have that little green icon, because then otherwise it won't work. It only works with with Alembics that can be interpolated.
All right. So I guess we'll try the last thing. So the Ferris wheel, I will do it next week because it makes sense. It's a part of the kit we have here. So the Ferris wheel is this, well, the Ferris wheel like that. And I'm going here to create this thing, which is much more difficult than looks. This distributor like that. You had to be very precise in order to make it work. So we'll see if I succeed and how it behaves. So, for example, I do have it here. Yes. If I hit play, and it's going to distribute them because of gravity, rotating like that. And it looks easy, but it's not. Ready? It's a pain. Okay, so let's try to do it by creating a new file. And actually, yes, for this one, I needed to have a size. So if I remember the size, let's go here. Yeah, it's 20 centimeter around this. Okay, not 100 centimeter, not 1 centimeter. Okay, so let's go here and let's try to create the shape. For this, I have a trick. I'm going to use the spline. I love using spline. It's so easy to just create thing. So I'm going to model everything, then I will scale it once I try the dynamic. So here, my hexagon, I'm going to move it on this axis. So 180 degrees divided by 6 hexagon is 30 degrees. So I have this like that. Okay. Now I'm going to make it editable. In my front view, let's go to point mode, and I'm going just to move this point down. Okay, and that will be my base shape. Let's go back here, and if I put that in an extrude object, let's make it like 20 centimeter. That will be the back plate. Okay. So here also I'm going to make it square weighted, so we have nicer shading. Well, we'd have so many bevel here, it doesn't really make sense. Well, let's create caps here, just a little bit of bevel, like 1 centimeter. And here with the subdivision, it looks nicer. Okay, so now I want to create the main thing. So I'm going to duplicate this end side and work from there. Okay, so here I'm going to hide this, and I'm going to move those points down. Okay, and now I'm going to move this point down. I don't want it to be flat. I want to make it like this to have a slope. And this slope is very important because that's going to make the ball roll. Okay, if it's too flat, it's not going to work because when it goes there, you must go this way. But if you make it too high, it's going to be a problem too. So maybe I'll adjust this later. Okay, so we have this. Let's go back and let's use an extrude, and this one will be bigger. Okay, so this is my main thing. This is backplate. Let's call it backplate. And here, that will be the base. Okay. And let's move it here so that they don't intersect. Okay, something like this. And now I need to create the divider here in the center. So for this one, I'm going to use a simple square, change the size. I'm just going to edit the points. So let's go maybe here, make it editable, use the points. Those points, let's just contract like this. Okay, make it a bit higher. Because I don't want to have a perfect pointy triangle. That's difficult then to model and to do things with. This one, I'm going to make it much smaller like that. Right click, I'm going to subdivide. So I have an intermediate point here. And let's align it roughly like this. Okay, now again, rectangle, extrude, I mean. And let's make it this way. Okay, so that's my divider, the thing. And the geometry is important. I'm not even sure I have the right slope here. We will see. So now I'm going to put everything inside a connect object. So connect object, which is going to be right in the center of the world. That's why I didn't use Alt. And we're going to put the thing here. And now I'm going to keep the connect object in the center of the world and move the extrude so I have a better starting point. And we will see in the rotation how it's going to be if I need to have a different center. Okay, so this is my center right here, as we can see with the connect object. Okay, so now we're going to change the size of the whole thing. So we have something very big. I'm going to reduce it to 20 centimeter. So 20 centimeter on X, that's it. A is to frame it. And let's call it divider. Okay, so let's make it a rigid body object. And you guessed it, we're going to use here a connector, an angular connector. So it's going to stay put here in the display. We're going to make it much smaller because this is just huge, something like that. So this is just for display. I mean, it could be the size of a truck. We don't care. Okay, and it's perfectly centered with everything. Okay. Our connector here, I have my divider. So now if I hit play, it's going to stay put almost because it's perfectly balanced. So that's interesting because I know it's balanced, it's symmetrical, but it goes this way. Okay, so that's interesting. That's better actually because we want to have a little bit of what's the word? To have some room for the thing to move. Okay, so my connector here, I'm going to use the angular limit. So these angular limits are difficult to every time I don't really know. I always confuse which way it's going to work. I think it's like this. So I put minus 45, 45 is going to move this way or this way. You can see this plane here is my initial, and it's going to move up this way or down this way. So that should restrict it the way I want. Let's try. Perfect. Yeah, got lucky. So it looks like we are ready. So I need now to use the ramp to make the our balls fall. So I'm going to save this divider 0, 1. I'm going to just recycle in my kit small here. I'm going to recycle this thing, which is one of the part of my kit. We will see next week. Okay, straight down. I'm going to save it, to copy it, move it here. And now we're going to rotate 90 degrees. Here, let's change the coordinate to 0. So it's a line, this one. Let's move it. And about the size, I just screw it up because I know that this is the right size. I should have gone this way. So my divider, I'm going to change the size. And because I start on the center, that just should work because my connector is still at the right place. Okay, now if I move this, I'd rather move this one. And try to align it. Okay, that looks good. I'm really wondering if it's going to work at the first try because it's really the case. I'm going to create one marble, move it here. So I'm making sure it's not too big. It should be 6 centimeters. I think that's the right amount. And let's make it dynamic. And here, like Tennessee said, very important, you need to change the thickness because it's a 6 centimeter sphere. 1 centimeter 5 is much too thick. We need to reduce it to maybe 0.1 or 0.2. Let's try 0.1. Lower than that, it's going to not work. You would need to increase your subdivision and so on. Also here in the collision shape, I'm going to change it to sphere. I think it's going to use this model anyway, but I like to force it. So I'm sure it's going to work the way it should. Here I have already triangle mesh, and our divider here, it's very important. I need to change the collision shape from auto to triangle mesh. Otherwise, it's going to create a hole, meaning that this part here is going to be full, not empty. So it wouldn't work. Okay, and now we can just launch it. And as you can see, it doesn't move anymore this way. So I'm going to change a few things. Here in the scene, let's reduce the scene scale to 10 centimeters. And then I'm going to change also, I think it might be a bit too close from the thing here. Let's try. No, that's not the problem. Okay, I'm going to change also here on our divider the thickness to 0.1. Maybe that's going to be enough. Okay, it's moving. So now I need to change the mass because this object is too thick, too heavy compared to this one. Okay, so either I'm going to take my sphere and make it bigger, so more dense, it will have more energy, and maybe it's going to make it move more easily. Let's see. Yes. Okay, so we're getting there. As you can see, I'm almost there. I think we need to, yes, we need to lower the whole thing. So I'm going to take my connector and divider. It's very precise, and it makes sense because it would be the same thing in real life. To make something work, you have to be very precise. Okay, it's almost there. I think I can move it down a bit more. And still not enough. So again,
Did you change all the thicknesses on the?
yes,
Okay.
yes.
There we go.
Oh,
Congratulations. Félicitations.
yes, thank you, merci. So now to check if it really works, because it worked for one ball, but it must work for a lot of other balls, I'm going to duplicate my sphere. And this one here, we're going to deactivate here enable. So deactivate enable. It's not going to play to do anything. Let's play a few frames. Let's wait at least here. So 57, why not? I'm going to enable the dynamics. So this one is going to roll. So first ball, second ball, almost stuck. But it's going this way. Now you have to write to find the right rhythm, the right frequency when these balls, these marbles are going to appear. So I'm going to duplicate a bit like this. I'm going to stagger the keyframes. And now this is my
Wait, I have a
second
proposal.
one.
I have a proposal.
Yes.
Try and raise the center of gravity of your flip flop, whatever that's called.
Yes, I tried that already. Actually, I even offset it a little bit, and it works. It works. So maybe I'm going to do that. Yes. Okay, that works. This one, this almost. This one goes the right way. You see, you had to find the right. So something I did too is go to the divider in the dynamics since Cinema 4D 2025, I think. You can have a damping, personal damping for this thing. So if I increase maybe a little bit the damping, angular damping. Yes. Yeah, I have to find the right rhythm. And like you said, we could also play here with the collision mass with the custom center. Maybe offset it. I would say down or up. Down.
No, up, because down it will bring it back in the position. Whereas if it's higher, put it higher. When it tips over,
Yes.
it's going to stay on one side.
It's 1 centimeter is a lot, but we'll see.
It's not heavy enough. Yeah. So now you just need make it a bit less, 0.2, 0.3, and I think you're getting there.
0.5. And yes, I'm going to stop here anyway, because now you're going to use a lot of settings, a lot of trial and error before you find the right balance. So maybe here on this thing here, I can try on the mass to lower the rotational mass and the density too. That works pretty well. Maybe 0.2. Yes. Second one. The first trial was the best. So maybe 0.2. But I will stop. You see what you need to do. So now it should. That's infuriating. Every time that drives me mad. Hey, go. Maybe it's my dynamics here. I went too far on the maybe 12%. No, that won't do. So maybe here I could change the slope, but that's something to do later. Anyway, with a lot of fiddling, at some point you can get something that works perfectly, like this one, which is like clockwork. And I had to find the right rhythm with the Ferris wheel. So a lot of work.
Yeah, there's always a lot of work in tweaking stuff. Yes.
So yeah, that's it. Only 15 minutes late. So that's not too bad. So maybe there are some questions.
There are a couple of questions in French. It will be, I understand the language barrier. It's good to go in English.
I see from JC Motion Designer
Yeah.
saying that's the kind of exercise I was expecting when I bought your training on simulation. Instead of floating flag and falling dominoes, I do love floating dominoes. I show them all the time. Yes, well, I hope you are happy with this one. Yeah, saying also, I hope there will be more advanced training. Well, the problem is when I make tutorials on Udemy and so on, when it's too advanced, it doesn't sell as much, and I earn a living with these tutorials. So I have to find the right balance. But I do offer some training with training center in France if you're interested, and also you can contact me, and I can find time to do that.
Yes, well, that was an amazing session again, showing us how you put together these amazing machines. And I think that everyone will be looking forward for the next two sessions, right? We have two more, don't we?
Yeah, the next one will be fun because it's how to construct this thing. Actually, all the segments have a scale, a size that makes it easy to construct. You're just going to snap all this, and I'm going to try to make something similar live using the kits. And before we will see how to create these kits elements, because it's interesting also about the modeling.
Yeah. There's one more question by our friend Drake. He asks, you may have already covered this, but in your shared scene files, there are two French plugins. Are they necessary?
French plugins?
Yeah.
On the file I shared last week? No,
We do not know.
This is the file I shared last week. No, there is no French plugin. I did everything from scratch. Maybe it's I don't know. That's weird. I will check the file. Maybe it's a leftover from something I removed. I don't know, but there shouldn't be anything, any plugin to use.
Yeah, we saw that happening without any plugins. Excellent. So yeah, I think we have concluded session number 2, and tomorrow we have the Ask the Trainer, and I'm going to be here answering your questions as much as I can. And yeah, thank you very much, Lionel, first of all, for hanging out and sharing your great knowledge with us and showing your beautiful work.
Thank you for welcoming me.
Always. And to all our viewers, have a great day. Now I need to find the buttons to press here. Let me see. It's not here. It's here. This is a live show, right? We're allowed to do this. We don't have directors and producers and all that. And yeah, just like that, you're going to get your end screen. Thank you very much, everyone, for coming, and have a great day. Bye.
Bye-bye.